Looking at the graph of b and c, we have 5x squared plus 2x over all square root over 3x. And if we take a look at the limit as it goes to infinity, we can see that it is definitely going towards a value of about, zero point 0.8, which is going to be root 5 over 3. Okay, so that horizontal asymptote looks like it is going to that point, and it's to do with the ratio if we compare the highest power in the numerator, which is square root of x squared, or just x. So we end up with coefficient of root 5, and in the denominator we have the coefficient of 3, so we just compare those two coefficients, and that gives us the endpoint behavior. Now for C, we're going to 0 from the positive side. And we can kind of see locally that we do have a domain restriction. It has a domain restriction at negative 2 over 5 or negative zero point 0.4. And as we approach 0 from the positive side, it's definitely going up to positive infinity. Now, this is a particularly difficult one because we had to kind of understand what was happening to this low power of root x compared to this high power of x as we get closer to 0. And so we could do this with an argument, but we could also do this algebraically by dividing everything by a power of just 1 over x. And by doing so, we can see that it went up to positive infinity from the right-hand side. And again, the graph confirms this. For the graph for D and E, we can see that as the graph goes to positive infinity, it's just going up to infinity. So we know that's just going to go up forever. So that's going to be our strong over weak argument. Now, as we go to 0, as x get closer to 0, the numerator, this part of the numerator becomes 0, this becomes 1, and essentially we're approaching 0 in the denominator, which is going to give us infinity. Since we're approaching from the positive side, we just need to look at this, but it does happen to have a two-sided limit, and from both sides of 0, because of the square in the denominator, it allows us to go to positive infinity from both sides. But this is a one-sided limit, and from the right-hand side, it does go up to positive infinity.